Hello class, this is Miss Cribb. I'm going to go through the part that we didn't get to in part of our class. We're going to go through the answers for the seat work, and we're also going to cover accuracy, percent error, precision, so that you'll be ready to do your homework assignment for today. Okay, first of all, for the seat work, we're going to write down the mnemonic device. So giga space, mega space, king, Henry, drank, ucky, dark, chocolate, milk, space, micro, space, nano. All right, remember nano is 10 to the minus 9. This is 10 to the minus 6. This is 10 to the minus 3. This is 10 to the 6th. This is 10 to the 3rd. 10 to the 9th power. All right, now we're going to use our information to convert. We're going to convert 1.89 days into minutes. So we're going to use bridge notation because bridge notation is what you're going to need. So 1.89 days. We're going to go from days to hours to minutes. That's the easiest way. You could go straight from days to minutes if you knew that. So I'm going to go days to hours to minutes. So there are 24 hours in one day. So notice the days are on the top and the bottom. They will cancel. I'll be able to cancel those out. Okay. And then there are 60 minutes in 1 hour. Notice the hours are on the top and the bottom, another diagonal line, canceling those out. So now it's 1.89 times 24 times 60. And when you put that in the calculator and multiply it all the way through, that is 2,721.6. And the unit that we did not cancel out is minutes, and that's minutes. This is the bridge notation, and I wanted it in minutes. My units that I did it's in minutes. So there's the final answer. Now let's do the next one. Milligrams to kilograms. Milligrams is right here. Kilograms is right here. So remember that this U stands for the unit, the basic unit without the prefixes. So a grams is the basic unit without prefixes. We're going to go from milligrams to grams, and then from grams to kilograms. Okay, so let's write it out. Okay, that's milligrams. All right, how many milligrams in a gram? Remember that there are 1,000 milligrams is equal to 1 gram. Or you could also say 1 gram is equal to 10 to the minus 3 milligrams. That's why there's a 10 to the minus 3 right here. These are both the same. So I usually use this one right here. I usually use this one just because it's not that difficult to remember for me. So 1 gram, 1,000 milligrams. And the next portion, now go back up here, milligrams here, numerator and denominator. I can cancel those out. We have the 1,000 number still in there to use though. And if I stopped my work right now, all my answers would be in grams. But I got to go to kilograms. So there are 1,000 grams is 1 kilogram. So that's the equivalent relationship there. So 1 kilogram on the top, that's the unit I need, and 1,000 grams on the bottom. Again, you can see the unit on the top, numerator and denominator, and they can cancel each other out. Now I can put this number, it's going to be 567789.9 divided by 1,000 and divide again by another 1,000. And then we'll get our answer. Okay, when I put that in the calculator, that answer is 0.5677899. You got to have all those numbers, and the unit that was not canceled out is kilograms. And I will accept this. You could put that one in scientific notation if you want to, but this is okay. All right, now let's do this next one. 238.44 millimeters to meters. So I'm going to go up here for a minute and erase this part. Okay, now we're going to go from millimeters, this is milli, to meters. Okay, the meters, a meter is a base unit. It has no prefix. So millimeters to meters is just one step. Okay, so 238.4 millimeters. And there are 1,000 millimeters in 1 meter. So 1 meter is 1,000 millimeters. Hopefully you remember a meter stick, and we can do that to help us to just visualize that. Okay, millimeters cancel out so that you have just meters left. So you just need to divide by 1,000. So that ends up being 0.2384 meters. Okay, and one more, liters to milliliters. Okay, so let's go back up here to the top, and let's erase this. For this we have 0.00355 liters. And we're going to go from liters, which is the base unit. A liter has no prefix. That makes it a base unit. We're going to go from liters to milliliters. And so that's a one-step process. So there are 1,000 milliliters in 1 liter. So this time we're going to multiply by 1,000. And that ends up being let me write it better. 3.55 milliliters. And you can notice that liters is on the top, liters on the bottom. We can draw a diagonal line there and cancel those out. Okay, so that's the answers to the seat work that we did. And check your own work against this. This is how you use the bridge notation for it. Now what I'm going to do is go ahead and talk to you about this part we didn't get to. Accuracy is the accuracy of a measurement or an instrument is a numeric evaluation of how close the measured value is to the actual or accepted value. So how close is it to the real thing? So which is more accurate? You have a football field. Is it 50 yards, 75 yards, 95 yards, or 155 yards? Well, the most accurate measurement would be 95 yards. All these other guys are not accurate. So accuracy is getting close to the real value. Percent error is this formula right here. You need to memorize this if you're honors. You'll be given this if you're not honors. Percent error is the actual amount minus the experimental amount divided by the actual amount times 100. Notice that it's always going to be positive because it has these absolute value symbols right here. You can see other ways of doing this. You might see a theoretical minus experimental, like your math, if you use math. But we're going to use this one right now. Example, you measure the mass of a product of a chemical reaction, the mass to be 3.80 grams. According to your theoretical calculations, you should have attained 3.92 grams. So what's the percent error? So here, theoretical is the same thing as the actual. We'd put theoretical here and here. The measured amount of an actual reaction that you did, this is an experimental value. So this is the theoretical amount, is always the amount in the best scenario that you would get. So we always write the formula, always. So percent error, I will take just a percent E equals, and this time I'm going to use a T. The theoretical minus the experimental over the theoretical times 100. So you just now you can fill in the values. The absolute value of 3.92 minus 3.8 divided by 3.92 times 100, and put it in your calculator. What you should have gotten is 3.06%. Now we haven't done sig figs yet, so this is going to be okay. Now when we do significant figures, we're going to have to calculate this number slightly differently. We'll update it when we do our sig figs. So I want you to notice, because the absolute value, I could have subtracted 3.8 from 3.92. As long as I divide by the correct thing on the bottom, it will give me the exact same number of 3.06%, because even though this would have been a negative number, the absolute value would have turned it back into a positive number. Okay, so that's a formula you're going to need for your percent error calculations on your homework. Now, precision is how repeatable a measurement is, or how exactly one can make a measurement. The more decimal places, the more precise it is. So look for this. Which is the most precise? Well, in this case, we only have 2 decimal places. Here we have 3 decimal places, but this last one has 4 decimal places. That means our instrument can get all the way down, tenths, hundredths, thousandths, 10,000th spot. That means it has enough markings between each spot to get down to the 10,000th spot on the ruler, or in this case this is grams, so to get down to the 10,000th of a gram. So the more decimal places, the more exact, the more precise the measurement is going to be. Here's a pictorial representation. This particular one is not accurate and not precise. We have different spots all over. This is accurate but not precise. And the reason is you kind of do an average. You draw, connect the opposite ones, and you notice that when you do the average, it falls within the bullseye. Over here, if I did that, it does not fall within the bullseye. So this is accurate when you average all those together, but it's not precise because they don't land in exactly the same spot. Here, we average, we draw the lines, and we are it's definitely not accurate. It's far away from the bullseye down here. But it is very precise. I keep making the wrong mistake, and I keep hitting the same spot. Okay, I'm making the same mistake over and over again. This one is accurate and precise because you draw those, connect the dots. It's right in the middle of the bullseye, plus they're all really close together. So that's the difference between accuracy and precision. Now we're going to start sig figs our next school day, so I hope this will help you.